Suppose you want to know what is the average math 10 score in a university, in a college. What are we going to do? We're going to take one sample and we're going to find the mean of that sample, and then we're going to form something that we call the confidence interval. The confidence interval is an interval including possible estimates for the population. Very good. Confidence interval. Well, I expect you to ask, how should I construct a confidence interval? First of all, that depends on the population parameter. So we're going to list each one of these separately. To find the confidence interval for population mean, so this is our first category, population mean. First of all, we need to find the point estimate. So step one, find the point estimate. Well, what is a point estimate? Point estimate is a value that is unbiased and that estimates the population mean. So officially, we define it this way. A point estimate is a single value, estimator of the population. So question is, when you're trying to estimate the population mean, what is the best point estimate? So the best point estimate for population mean is sample mean. So in step one, I need to find the point estimate for population mean, which is sample mean. Sample mean. Step two. Step two is to find the confidence level. Find the confidence level. So what is a confidence level? When you're talking about confidence level, the confidence level is the probability that your interval actually contains the population estimate. The probability. The probability that the interval contains the population estimate. That's the definition of confidence level. So far, we talked about the point estimate for the mean, which is the sample mean. Now we define the confidence level, the probability that the interval contains the population estimate. We have some famous confidence levels. One of them is 90%. The other guy is 95%. And the other guy is 99%. As a statistician, when you're working with different projects, you might end up seeing your employee ask you, hey, I want this project to be 90% confident. I want the project to be 95% confident or 99% confident. Either the boss tells you what percentage they want, or if it's not given, we always select 95%. So quick note for you. If it is not given, use 95%. So when you read the question, read the project, and you see, okay, I cannot find any confidence levels, it means that it's not given to you. In general, if it's not given to us, we use 95%. Okay. After finding the confidence level, you need to find something that they call the critical value. Step 3, find critical value. Critical value is denoted by Z sub C. This is a Z score associated to your confidence level. ZC or critical values are values that separate the sample, probable sample statistics, probable sample statistics, which is, in this case is sample mean, from the improbable ones. So ZC. How do I find ZC? To find the critical value, if you have 90%, 95%, 99%, you're going to follow these steps. You have to use your calculator, critical value. Calculator. Very good. First of all, for 90%, the 90% of the area is below the graph. 90%. So let me use some colored markers. So you have 90% below the graph, all right? Because of symmetry, you're left with 10%, which are divided into 5% and 5%. So here you have 90% of your area. 90% confidence level, the probability, the area. This is your 90%. So 5% is left to the left and to the right. This is your 5%. 0.005. Remember that when we introduce the area and finding the Z value, we use inverse norm. So go to second, vars, find inverse norm, enter the following. The area is 0.05. The mean, since it's a Z value, is 0, and the standard deviation is 1. After punching this, it gives you a number to the left-hand side. To the left-hand side, what you get is negative 1.645. Negative 1.645. The Z value is a positive number. The Z score is on the right-hand side of this negative Z score. Your ZC is positive 1.645. So So for 90% confidence level, the critical value is 1.645. This is for 90%. We have to repeat this for 95%, for 90%, and so on. So for 95%, this is your normal distribution. 95%. 95%, well, you take more area than 90%. So you have 95%. 100% minus 95% is just 5%, am I right? This 5% is divided up into two equal portions. This little area, which is 5%, divided by 2, which is 0.025. This is this little area here. So again, to find the z, you need to go to second Ward's inverse law. So second Ward's inverse law. Very good. Okay, what is this z? So we have 95%. The area is smaller than 5%. The area is getting to the left-hand side. So if you do the calculation, the z-score is negative 1.96. This is my z-value. Guys, critical value must be positive, the absolute value of your z-value. So your critical value, which is on the right-hand side, positive sign, is positive 1.96. ZC critical value is 1.96 for 95% confidence level. And finally, if we have 99%, it means that we are taking the majority of the area. 99%, guys, where is that? It's here, 99%. Here we go, 99%. Well, okay, let's do a little bit of algebra. I want to know what is this little area. 100% minus 99% gives me just 1% back. This 1% is divided up into two portions. One portion to the left, one portion to the right. Is 1% divided into two portions. 1% divided by 2 gives me 0.005. Very small area. This is the small area down here. So you go to second Ward's. This is 0. Second Ward's, and you find the inverse norm. Okay, so what is my z-score and what is my critical value? Guys, critical value must be positive. These are all approximately 2.58, negative 2.58, but ZC on the right-hand side, the critical value is positive 2.58. These are all approximations that we're using for 99% confidence level. Very good, excellent. So we're just done with step 3. We have more steps to take. In step 4, we need to find a margin of error. And in step 5, we need to find the confidence interval itself. Now, so far we learned how to find these critical values. Now I need to erase this part of the board. To write down step 4 and step 5. In step 4, we need to find the margin of error. Margin of error, what is that? Denoted by E. Very good. When we're talking about margin of error, we're actually finding the greatest possible distance between the point estimate and the population parameter that we're trying to estimate. So this is the largest distance, between the sample or the point estimate and the population estimate. We have two possible scenarios. For population mean, sometimes the population standard deviation is given. So if sigma is given, then the margin of error is equal to ZC, the critical value that you found, times sigma over square root of n. However, if sigma is not given, we cannot use ZC. We have to find something that we call T sub C. So if you are in the case that sigma or population standard deviation, sigma or population standard deviation is given to you, go ahead, go to the step 4 and find the margin of error. And finally, in last step, step 5, find the confidence interval, which is your point estimate minus margin of error minus E, comma, point estimate plus margin of error. So step by step. Find point estimate, which is sample mean, X bar. Find the confidence level, either 90%, 95%, 99%. Find the critical value associated to each of these confidence level. And then in step 4, find the margin of error, which is E. If sigma is given, margin of error is ZC times sigma divided by square root of n. And finally, find the confidence interval, which is an interval, open interval, point estimate minus margin of error, comma, point estimate plus margin of error. This guy is called the lower limit of your interval, and on the right hand side you have the upper limit for your interval. Your interpretation is we are blank percent, depending on which one of these percentages is given, blank percent confidence that the population mean is between X bar minus E and x bar plus a. Let's take a look at one example to feel comfortable about finding the confidence interval for population mean. So in this question, we have the following information. A college admissions director wishes to estimate the mean age of all students currently enrolled. So what are we trying to find? What are we trying to estimate? It's the mean age. We're trying to estimate the age of the population. What is the mean? What is the average? In a random sample of 20 students, so we have 20 students, the mean age is 22.9 years. Question says, from past studies, the standard deviation is given as 1.5 years. This is for the population. And the population is normally distributed. Question says, hey, construct a 90% confidence interval of population mean age. There we go. So let us go to the board, fill in the blanks. So in this question, what information are given to us? Let me erase the definitions. So first of all, you should be asking that, is the standard deviation of population is given? Do I have any information about population standard deviation? What is that? The population standard deviation is given to me. It says from past studies, the population standard deviation is 1.5 years. So since I have the standard deviation of population, I am allowed to go and find ZC. Otherwise, I have to find a different critical value that we call T sub C. So what's the point estimate? We know that we have a sample. What is the mean age in that sample? What is X bar? I also have X bar, or the sample mean, which is 22.9. These are the information that I have. What is the confidence level? Take a look at your question. One by one, we identify each one of these. What is the confidence level? Confidence level. Do I have any information about confidence level? It's directly given to me as, thank you very much, 90%. 90%. C is 90%. I'm going to put all of these in the circle so I don't forget about this. What about critical value? Remember that to find the critical value, we can always go to your calculator. Here you have your 90% of the area. 100% minus 90% is 10%. Half of the 10% is just the area is to the left, which is 5%. Half of the area is to the right. Since my calculator only take on the left area, I'm going to use the left area to find Z. After finding Z, I can easily find my critical value. So to find critical value, the area is 5%. We go to our calculator, second, vars, inverse norm. Very good. We enter. Area is 5% on the left. And here you have 0. The mean is 0. Standard deviation is 1. It gives you negative z value, negative 1.645, and ZC is the absolute value of this number on the right-hand side. Your critical value is 1.645. Now we go to step 4. What is the margin of error? Since we have Z, we can find margin of error, which is ZC, sigma divided by square root of n. ZC, hey, I have ZC, 1.645. Sigma, I have sigma, 1.5 years. Divided by square root of, what is n? What is the definition of n? N is my sample size. What is my sample size? How many students were in that sample?
20.
Very good. Take a look at the question. 20 students. So the sample size is just 20. Well done, everyone. 20. Square root of 20. Now you have to use your calculator to find an approximation. What is the margin of error? So we found margin of error to be approximately 0.5. This is my margin of error, 0.5. So E is approximately 0.5. Do I have all the information? Yes, I have all the information to construct my confidence interval. My confidence interval is equal to, I have a parentheses, open interval. So open interval, what is my point estimate? My point estimate is 22.9. So 22.9 minus the margin of error, 5%, and 522.9 plus margin of error. Very good. So what do I have? This confidence interval is, it gives me the range of ages. So here I have 17, 22.4, comma, and if I add these two, I get 23.4. So what's the meaning of that? It means that I am 90% confident that I am 90% confident that the mean age is between 22.4 and 23.4. So let me show you how to use your calculator to calculate the confidence interval. Calculator, there you go. To use your calculator to find the confidence interval, we're going to follow these steps. So this is my calculator, and here I have the steps. First of all, turn on your calculator. You need to go to stat. So to find the confidence interval, go to stat. Go to tests. Okay. Then you need to find your interval. So check each one of these separately. Z-test, T-test, two sample Z-test, these are all tests. I'm looking for the interval. I'm looking for Z interval. Take a look at the next one. The next one is T interval. T interval is for the case that sigma is not given. So find Z interval. Z interval, okay. Am I using data? Am I using any number set in the calculator? No. I'm using stats, information from the sample. So go to stat, go to tests, find the Z interval. After finding Z interval, click on stats. After clicking on stats, you need to enter information here. What is sigma? Sigma is population standard deviation, which in this example is given to us as 1.5. Then you need to type it down, 1.5. Go to the next line. You have your X bar. What is X bar? X bar is the sample mean, which is equal to 22.9. So 22.9. Then go to N. What is N? N is the sample size, which is 20. Okay, let's enter 20. What is the C level? What is the confidence level? The confidence level in this example was 90%, which is 0.90. 0.90. Then calculate. Here we go. You have your confidence interval. The confidence interval is 22.35, comma 23.45. Very good. So we are 90% confident that our mean age, mu, the mean age of the population is within 22.35 years to 23.45 years.